Emulators are a very important part of the development process. They simulate hardware where our apps will run, and they allow us to try out different hardware configurations, such as different screen sizes. They are also something of a pain point for mobile developers. Ask anyone who's worked extensively with the Android SDK emulators, and they'll tell you that they're generally considered to be slow and that they can hinder productivity. I've not found this to be any worse than, say, working with a web project, which might require you to restart the web server to see changes in a server-side module. In fact, maybe I'm just not that picky, but if you run an emulator as soon as you start working on your project and just leave it running, I think it's fine. We're going to take a look at working with the Android SDK Emulator Manager. This is a tool that is part of the Android SDK rather than part of being Visual Studio. The Xamarin platform simply provides a menu item in the Tools menu as a handy integration. To run the Emulator Manager, I'll click Tools, then Android Emulator Manager. This will launch the Emulator Manager program. Once I've launched, I can see that the Xamarin install has created a few emulators for me which correspond to popular configurations. Let's try one out. I'll click the emulator that indicates that it's API level 12. We'll discuss what this means in detail in a minute, but for now, just realize that an API level is tied to a particular release of the Android SDK and is also tied to a particular release of the Android operating system. When you buy a device, it has a particular version of the Android operating system running on it. Some devices will allow you to easily change or upgrade that version, while others may lock it down. Just understand that there are millions of devices out there in the wild all running different versions of the Android OS, depending on when they were purchased and perhaps the last time they were upgraded. In this case, API level 12 refers to release 3.1 of the Android SDK, where the corresponding operating system release was codenamed Honeycomb. I'll start the emulator by clicking the Start button on the right side of the AVD Manager's screen, and in the ensuing dialog box, I'll set some of the options that will resize the emulator when it launches. I'm doing this because my recording software limits the size of my screen. If I don't change the size of the emulator, it won't fit on the screen. I'm going to set it to 5 inches at 160 dots per inch. If you want to resize the emulator to fit your monitor configuration, fiddle with these settings until you find one you like. With that done, I'll click the Launch button. Since we have a little time before the emulator boots, it's worth noting the discrepancy between the title bar of this tool and the menu item in Visual Studio that launched it. In Visual Studio, it said Android Emulator Manager. But the Android SDK calls this Android Virtual Device Manager, or just AVD Manager. Be aware of the discrepancy, as developers will undoubtedly be using these terms interchangeably. The emulator will boot the Android OS and look just like a physical device would after a hard boot. Once the emulator comes up, you can see that you're essentially looking at a virtual Android device. I can slide the screen to open with my mouse, and from here I could, in theory, link my Google account, buy apps, or do anything that I could with a real tablet. I'm going to shut down the emulator now and show you how to create your own emulator with your specifications. I'll go back to the Android Emulator Manager screen, and I'll click the button labeled Create. Here I can see a screen with a lot of technical details on it. First, I have to give this AVD or Android Virtual Device a name. This is arbitrary. I'm going to call mine First Emulator. Next, I need to select the type of hardware I want to emulate. Google's reference hardware line is called Google Nexus, so it's not a bad idea to test against that. But later, you might want to try even less specific hardware emulators. For now, I'm going to pick the Nexus 7, which is a 7-inch tablet. In setting my API target level, I'm going to make an emulator for a slightly newer version of the hardware. I'm going to use API level 19, which corresponds to the Android release KitKat. KitKat isn't the newest release. It's actually 2 releases behind the current cutting-edge production release, and at least 3 behind the bleeding-edge SDKs. KitKat is a good choice for me because it's been out for a year or 2 now, and there are plenty of potential customers with this device. It's not too old, and it's not too new. Next, I'll select the processor that I want to emulate. Most of the hardware I've seen at my local computer store runs the Advanced RISC Machine, or ARM chip. And I think it's wonderful that not only has the RISC architecture never truly died, but also that we as an industry have managed to embed an acronym inside of another acronym. You'll want the keyboard checkbox checked so that you can use your keyboard instead of trying to type, and I'm using air quotes when I say type, everything with your mouse with the on-screen keyboard. It's hard enough when you have to do this with your thumbs on an actual device. It's going to be even worse when you try to do it with a mouse on a virtual screen. For the skin, I'm going to pick the skin with dynamic hardware controls. This is generic, yet affords us the ability to simulate most things that you'll find on a real device. There are other skins that are made to make your emulator look exactly like the device it's emulating. This one just gives you all the buttons you need in a convenient sidebar. If you're going to write an app that uses one or both of the cameras, you can make a selection for the front and rear camera settings here, which involves either playing some sort of animation to simulate a camera, or the emulator itself can use the webcams hooked to your development computer. My laptop has a camera, so just for fun, I'll pick it to be the front camera. You can set the memory to be used by the emulator. This is a great way to justify a new, beefier laptop with your boss. Just say you're running lots of virtual hardware and you need a faster machine with lots of RAM. For our case, 1024 is more than enough for what we're doing. The last two settings let you simulate storage on the device. Most devices come with some amount of onboard storage, and usually supplement that with an SD card slot. You can simulate these things by typing values into the respective text boxes here. There are two emulator options listed at the bottom, and you must be careful not to use them together. Snapshot will save the state of your VM between launches. This allows the emulator launch much faster. The second option allows your emulator to access your graphics hardware unit, or GPU. This might be important if you're writing an app that leverages high-end graphics features via OpenGL, such as a game or an advanced visualization app. When I click the OK button, I'm presented with a short summary of what I've just created, and I can click OK again to dismiss it. I can see my new emulator in the list, so let's try it out. As before, I'll click Start. This time I'll point out that there are a few extra options I can use when running my emulator. I'm going to set a nice size that will show up nicely on my display, the same way I did earlier. Additionally, you can see there is a Launch from Snapshot option and a Save to Snapshot option. There's also a setting that lets you wipe user data on launch, so if you did anything that your VM might remember between launches, such as link your Google account to it, you can choose to start fresh every time by wiping the data, which will present you with that new out-of-box experience you saw when you first launched the emulator for the first time. That's a nice segue into clicking the Launch button. My new AVD launches, and I can see it's a little different than the last one since it's a newer version of the operating system. I can also see all the nice hardware buttons on the skin over on the right side. These are buttons that would be on the hardware itself. I'm going to shut down this emulator by clicking the Close button. And that's a great introduction to Android emulators from Google. But we're not done yet. I want to show you another option. With Visual Studio 2015, Microsoft has made its own emulator platform available. If I click Tools, then Visual Studio Emulator for Android, we'll see we have a tool similar to Android's AVD Manager. The Visual Studio Emulator for Android, that's a mouthful, so why don't we just call it Microsoft's Emulator, affords us the same tools plus a little bit more capability. Since we just created and launched a Nexus 7 with KitKat, why don't we launch Microsoft's emulator for comparison? It's at the top of the list, so I'll click the green Start button and let that launch. At first glance, the difference seems to be cosmetic. It wasn't lightning fast to launch. I have a toolbar down the side like I did on Google's emulator. But the devil is in the details. If you examine more closely, you'll see you have a lot more control over this emulator. For starters, it's very easy to turn your virtual device by clicking these two buttons with the semicircular arrows on them. Above that, you can see we have support for multi-touch, which is a recent innovation in some of the latest devices. You can zoom in, which really just makes everything bigger. But now for the really cool part. If I click this button with the two chevrons on it, I can see the additional tools. Here we can simulate even more hardware scenarios using the accelerometer, GPS, network, battery, camera, and SD hardware. We have access to those things in Google's emulator from our program, but this is designed to simulate actually doing things to the device. For example, I can shake my virtual device vigorously using some recorded data supplied by Microsoft. I'll just click the play button, and I can see the X, Y, and Z coordinates in simulated space are going crazy. I can also tilt my device in 3D space by dragging it. While the AVD Manager is an essential tool for any Android developer to master, I think you'll find the Microsoft emulator a more rewarding experience. It can be configured to work with Xamarin Studio, or even Android Studio in a Java environment, assuming of course you're using Windows as your development platform.